limit of tangent and secant functions. So before we jump into looking for the limit of tangent and secant functions, let us review our understanding of the tangent and secant functions. So let f of x be equal to tangent of x. The domain of this function is the set of real numbers except this. Pi over 2, 3 pi over 2, odd multiples of pi over 2. The range of your function y is equal to tangent of x is the set of real numbers. Now let us recall that tangent of t is equal to sine of t divided by cosine of t. Let us go back to how we are defining our circular functions. Sine of t and cosine of t and tangent of t. So if we are given a real number t, that real number t, we can wrap it around our unit circle, and that real number t is going to produce an arc in our unit circle. And this arc has a terminal point. And guess what? The first coordinate of that terminal point is cosine of t. The second coordinate of that point is sine of t. So if you want to get what is tangent of t, all you have to do is compute for sine of t divided by cosine of t. Now what if our arc has a length of pi over 2? The terminal point of pi over 2 is going to be 0 and 1. Cosine of pi over 2 is 0. Sine of pi over 2 is 1. So that means tangent of t is 1 over 0. So that means tangent of t is undefined when t is pi over 2. And the same reasoning goes with when t is equal to 3 pi over 2. So that arc has a terminal point, and the coordinates of that terminal point is 0, negative 1. So what is tangent of 3 pi over 2? Again, it's negative 1 over 0. It's undefined. So you can now see why we have to remove pi over 2, 3 pi over 2, and the odd multiples of pi over 2 from the set of real numbers to produce the domain of your tangent function. Now, how about the range? I hope that you can still recall the graph of your tangent function. So obviously, your tangent function is going to have vertical asymptotes. So because your tangent function is undefined when t is equal to pi over 2 and 3 pi over 2, so you can draw these vertical lines. Those lines are going to be the vertical asymptotes of your tangent function. And you know what happens? You know what happens when a function approaches its vertical asymptotes? It can either go to infinity or negative infinity. And so that's the reason why the range of your function is the set of real numbers. Now why is it? Why is it when your t approaches pi over 2 from the left, tangent of t goes to infinity? Why not to negative infinity? Okay, we are approaching here pi over 2 from the left. So that means t is less than pi over 2. So again, you have to go back to your unit circle. So when your t is approaching pi over 2 from the left, okay, like this. So that means your t is less than pi over 2. So that means you are here in the first quadrant. And in the first quadrant, sine is positive, cosine is positive, and so when you compute for sine over cosine, it's positive. And so that's the reason why our tangent function goes to infinity in this part of your graph. On the other hand, if you are to approach pi over 2 from the right, that means, look at this, you're approaching pi over 2 from this part. This is the second quadrant. And in the second quadrant, sine is positive, cosine is negative. And so if you are to compute for tangent, tangent is going to be negative. And so here, your tangent function is negative, but as it approaches the vertical asymptote, it approaches negative infinity. Secant of x is equal to 1 over cosine of x. Here you can see right away that we have restrictions for the values of x. X can be any real number except pi over 2, 3 pi over 2, add multiples of pi over 2. Now, the range of our second function y is equal to secant of x is this. It's the union of two intervals, -1 to negative infinity, union 1 to positive infinity. For most students, they cannot see right away why this is so. We have to go back to the graph. And of course, I doubt it if most students can easily recall the graph of the second function. Again, let us look at the domain. Why is it that the domain of the second function y is equal to secant of x does not include pi over 2, 3 pi over 2, 5 pi over 2, so on and so forth, the odd multiples of pi over 2. Again, we have to go back to our unit circle. When t is pi over 2, the terminal point is again a point with coordinates 0 and 1. So secant of pi over 2 is 1 over cosine of pi over 2. And so that means secant of pi over 2 is going to be 1 over 0. That is undefined. And so that is the reason why we have to remove pi over 2. The same with 3 pi over 2. The same with 5 pi over 2. All of that, we have to remove that from the set of real numbers. And that is going to be the domain of your second function. Now, how about the range? Okay, look at this. Look at this. So this is the union of two intervals. One is from -1 to negative infinity, and the other one is from 1 to infinity. So when you're combining intervals, these are sets, you don't use plus, you use union, because that is the operation when you combine sets. Now, I have the feeling that you cannot quickly see in your mind the graph of secant of x, or y is equal to secant of x. So this is what you can do. Produce the graph of the function y is equal to cosine of x. Okay? And from this graph, we are going to produce the graph of y is equal to secant of x. Now we know that our second function would have vertical asymptotes. These are pi over 2, 3 pi over 2, negative pi over 2, all odd multiples of pi over 2. Okay, so look at what's going to happen. When x is 0, cosine of 0 is 1. Okay? And when x is 0, secant of 0 is also 1. Okay, now look at what's going to happen. When the value of your x goes to pi over 2, your cosine function will decrease. But because your second function is the reciprocal, it's the reciprocal of your cosine function. So if your cosine function will go here, it will climb down the stairs, so to speak. Your second function will climb up. And it will go to infinity. And that is how graphs behave in relation to their vertical asymptotes. Okay. Now, how about this? Let's say, for example, x goes to pi over 2, or it is approaching pi over 2. So again, here you can see that our cosine function is climbing down the stairs and he wants to go to the ground floor. That's the ground floor. But second function is the reciprocal. He doesn't want to do what cosine is doing. He will do the opposite. And so if cosine function will go downstairs, secant will go up. It will go towards positive infinity. Now let us look at this. When x is pi, cosine of pi is -1. Secant of pi is also -1. Cosine now, coming from the basement, will go to the ground floor. But secant function is the reciprocal. So he will go to a floor that is even below the basement. That is even below the basement. Who knows? Maybe there's another floor below the basement. And so our second function will go down. It will go towards negative infinity. And the same thing happens here. When cosine climbs up, secant climbs down. Okay. So this is just a portion of the graph of your second function, and you will repeat this in other intervals. So here you can see now how and why the range of your second function came to be this way. It's the union, okay? It's the union of, this one is -1, going to negative infinity, and the set of real numbers beginning from 1, this one, going to positive infinity. Limit of tangent, secant, cotangent, and cosecant function. So the limit of tangent of x as x approaches a is just tangent of a. The same with secant, cotangent, and cosecant. So this is saying you that if you want to find the limit of your circular functions as x approaches a, you just evaluate the function at a, assuming that a is in the domain of your circular functions.